Okay, I want to thank our speakers one more time for their excellent talks. So now we're going to take you through a very quick, roller coaster journey with many abstracts. We have received so many abstracts. We would like to thank everybody who put their abstracts. There is a number of abstracts outside, so please have a look at them during your coffee breaks. But we've got 5-minute presentations for the winners of the abstracts. So I'm going to invite to the stage Mr. Keum from South Korea and his abstract on lesson learned from the nationwide 10K Rare Disease Genomic Project.
Thank you for the introduction.
Your time is start now. You have 5 minutes.
Yeah, I know that. 5 minutes, so short. So please assign more time next time. So I'm Changwon Keum from Dribbillion. Dribbillion is a company revolutionizing rare disease genetic testing by using the AI technology. So today I'm going to talk about what we learned from the Korean nationwide rare disease genome project. So sorry for the broken views due to the size issues. So just focus on the contents of the project. So the project was conducted for just a year, last year. 46 patients and their family members were recruited from 12 major hospitals in Korea, and the 30x whole genome sequencing was conducted for them, and finally the clinical diagnosis also provided for all of the patients participating in this project. Our work was a whole genome sequencing analysis and clinical diagnosis for all patients. And I want to mention that this whole project, from the recruiting to the final diagnosis, was completed within just 1 year. So the challenge is like that. So as you know, that recruiting the patients, it takes quite a lot of time. So actually, we only have 4 months to complete the analysis and reporting for 7,000 whole genome sequencing. You may know that how insane this schedule is if you know a little bit about how many times and manual curation was required for diagnosis using the whole genome sequencing data. So diagnosis by whole genome sequencing data is like this: finding one causal variant from 5 million genetic variants produced by the whole genome sequencing over each patient. So at first you need to precisely interpret the genetic variant according to the HMG guideline. At the same time, you need to evaluate the relevance of a patient's phenotype to possible genetic diseases. Finally, medical geneticists confirm the diagnosis by looking at the tens of thousands of genetic variants. So it takes about 20 to 40 hours to complete the whole genome sequencing rare disease diagnosis. But as I mentioned, we have very little limited time to analyze the data. So the last year, we need to complete the whole process for 44 patients in a day. So how we did that? We use our proprietary genome interpretation system called the Evidence. Evidence automates every processes. So it produced the variant interpretations with over 90% accuracies. And of course, it prioritized diagnosable variants in top 5 genetic variants with 97% accurate. What does it mean? So the diagnosable variants are within the 5 genetic variants. So medical geneticists are just looking at the 5 genetic variants rather than the hundreds of thousands of genetic variants for the final confirmation. So like that, we can reduce the time to less than 5 minutes on average to complete the diagnosis. And you can see the AI technologies developed for this project. And later on, you can check it later on. So this is overall result. 37% of patients get diagnosed, and 5% receive diagnosis with the inconclusive result of the BUS, and patients with more than 1 family members receive 41% of diagnosis, which is 15% more than the patient participating alone. The 60% receive the diagnosis with the novel variant. 40% receive the variant inherited from their parents. And the detection rate ranges from 10 to 60%. And the lowest detection rate goes to the tumors groups. tumor groups, the second largest or phenotype groups here, and 20%, it comprises 20% of populations. So if you filter the tumor group patients, then the detection rate overall goes up to 42%. So whole genome sequencing is the best option for diagnosing rare disease patients. It detects all types of genetic variant, including the mitochondrial genomes. So if you use an exome or a CMA rather than the whole genome sequencing, then we might miss the 6% of the diagnosis for rare disease patient. So that's it. 3 billion provide the CAP and CLIA certified genetic testing services for rare disease patient. So let me know if you need our help. Thank you. So great. Thank you. Thank you.
Okay, our next speaker is from India, Dr.